We are Team Supernova, and today we are presenting our full stack project Slateboard. Our team consists of Priyanshu Kamal, Shivani Butolia, and Madhav Singla. We worked collaboratively throughout this project, combining our ideas and technical skills to build a meaningful solution. Today we will walk you through the concept, key features, and the outcomes of our project. Let's begin with the idea behind Slateboard. Slateboard is a canvas-first virtual whiteboard designed specifically for teachers and students. The core philosophy is simple: drawing should come before everything else. When a user opens the app, they are immediately placed onto the canvas, ready to draw. No login setup, but we will log in first. As you can see, we will walk through sign in option, then you can register also and log in. I will log in. As you can see the interface, in learning environments, even small delays can break focus. So instead of onboarding screens or menus, Slateboards prioritizes instant usability. Now moving to the core features. The most important feature is the draw first canvas system. The canvas is always central, allowing users to start working immediately. So let's start. We go to dashboard. This makes the tool intuitive and natural, whether you are teaching or learning. Next, we have a rich and customizable drawing toolkit. The pen includes like multiple color, you can see adjustable stroke width, opacity control for highlighting. This allows user to create clear and structured explanations. For example, bold diagrams, light highlights, and differentiated lines all in one place. Like I can draw anything. The text tool allows users to add labels anywhere, making explanations more structured and easy to understand. Additionally, we have an eraser, as you can see. This ensures all tools are clearly visible even in classroom settings. Now, my teammate Shivani will explain further.
Thank you. Now I will explain the collaboration system of Slateboard, which is one of the most important aspects of our project and a key factor that makes it suitable for real-world classroom and group learning environments. Slateboard is designed using a real-time multi-user architecture which allows multiple users to join the same board and interact with it simultaneously. This means that instead of working individually, users can actively collaborate on a shared canvas just like they would on a physical platform. This real-time interaction is powered by WebSocket communication, which enables data continuous two-way data transfer between client and the server. Unlike the traditional HTTP requests, where communication happens in isolated steps, WebSockets maintain an open connection. This allows data to be sent instantly without delay, and which is very critical for achieving smooth and responsive collaboration. When a user starts drawing on the canvas, the system does not wait for the entire drawing to be completed before sharing it. Instead, the drawing process is broken down into small, continuous events. For example, when a user strokes, which indicates the starting point of a drawing, each movement on the cursor which captures the path of the stroke, when the stroke ends, which finalizes the drawings. Each of these events is immediately sent to the server and then broadcasted to all other users connected to the same board. Because this process happens continuously and in real time, other users can see the drawing being created live, point by point. This creates a synchronous drawing experience where it feels as if all users are working on the same physical surface. There is no noticeable delay, and every action is reflected almost instantly across all participants. To, to better understand this, consider a classroom scenario. A teacher is explaining a concept by drawing a diagram on the board. As the teacher draws, all the students connect to the board and can see the diagram forming in real time. At the same time, students can also contribute by adding their own annotations, solving parts of a problem, or highlighting specific areas. This creates an interactive and engaging learning platform. Another important feature in collaboration is user presence awareness. In a multi-user environment, it is important to know who is performing which action. Slateboard addresses this by visually distinguishing users, typically through unique identifiers or colors. This ensures that users can easily identify contributions and avoid confusion during collaborative sessions. We also use a room-based collaboration system, where each board acts as a shared collaborative space. Instead of requiring complex setup or invitations, user can join a board simply by accessing a unique link. This makes the onboarding process extremely simple and efficient, especially in classroom environments where quick access is essential. Another key aspect of collaboration is synchronization. This system ensures that all users have a consistent view of board at all times. Even if a new user joins in the middle of a session, they do not see an empty board. Instead, the current state of the board is loaded and displayed immediately, allowing them to catch up without missing any prior work. In addition to this, we have an AI chat assistant which enhances the collaborative experience. This feature allows users to ask academic questions while working on the board. AI responds with concise educational answers, helping the users to clarify concepts without leaving the platform. It is important to note that AI is strictly academic in nature and designed to support learning rather than distract from it. All these collaborative features are built on event-driven architecture where every user action is treated as an event and efficiently transmitted across the system. This design ensures scalability, responsiveness, and reliability. In the summary, the collaboration system in Slateboard provides real-time multi-user interaction, continuous and smooth synchronization, simple and quick sharing through links, clear user preference and identification, integrated academic support through AI. All these elements work together to create a highly interactive and effective collaborative environment. Now we'll pass it to Priyanshu, who will explain the backend architecture and performance optimizations behind the Slateboard.
Thank you, Shivani. Now, I will explain the technical foundations of Slateboard, including its backend architecture, system design, and performance optimizations that ensure a smooth and reliable user experience. Slateboard is built using a decoupled client server architecture, which means that the front end and back end operate independently while communicating through well defined interfaces. This separation allows for a better scalability, maintainability, and flexibility in development. On the front-end side, we use vanilla JavaScript along with HTML5 Canvas API. The core component here is the Canvas engine, which is responsible for rendering all drawings on the screen, handling user inputs, and managing interactions such as zooming and panning. The Canvas engine operates using a continuous rendering loop, which ensures that drawing operation appear smooth and responsive to the user. On the backend side, we use Node.js and the Express framework. The backend is responsible for handling API requests, managing user sessions, coordinating real-time communication, and the integrating additional services such as the AI assistant. For real-time communication, we rely on Socket IO, which enables low latency bidirectional communication between client and the server. This is what makes real-time collaboration possible, as it allows drawing data to be transmitted instantly between users. One of the most important architectural decisions in our system is use of hybrid database strategy. We use two different types of databases. MongoDB, which is a NoSQL database, is used to store the primary application data, such as boards, strokes, and user generated content. This is ideal because drawing data is complex and hierarchical in nature. PostgreSQL, which is a relational database, is used for structured data such as activity logs, analytics, and audit trails. This combination allows us to take advantage of the strengths of both database systems. MongoDB provides flexibility and speed for handling drawings data, and PostgreSQL ensures efficient querying and analysis of structured information. Now, let us discuss the performance optimizations that make Slateboard efficient and scalable. The first optimization is the use of vector based data storage. Instead of storing data as images, we store them as mathematical representations of strokes, which consists of points and paths. This significantly reduces storage requirements and allows for smooth scaling and editing. The second optimization is the use of the path simplification algorithms, such as the Raymer-Douglas Puker algorithm, which is a user draws a stroke, many points are captured, some of which may be redundant, and this algorithm removes unnecessary points while preserving the overall shape, resulting in more efficient data storage and faster rendering. The third optimization is event streaming. Instead of sending entire drawing over the network repeatedly, the system sends only small incremental updates. This reduces bandwidth uses and ensures that the application remains responsive even during heavy uses. The fourth optimization is the implementation of the rate limiting and payload control mechanisms. These ensure that the server is not overwhelmed by the excessive requests, that the system remains stable even under multiple users are active simultaneously. The AI chat feature is also optimized for performance. Finally, the entire system is designed to be robust and reliable, ensuring that the user data is preserved and that the platform performs consistently under different conditions. To conclude, Slateboard is just not a simple whiteboard application. It is a carefully engineered full stack system that integrates real time communication for seamless collaboration, advanced rendering techniques for smooth drawing, efficient data storage and processing, and a user focused design philosophy. All of these components work together to create a platform that enhances teaching, learning, and collaborative problem solving. Thank you.